welcome guys, welcome for this part. So in this part, we will going to define work as we have already discussed what exactly is the work in the introduction part, but this part will going to define what precisely what is a work and its nature. That means whether it is a positive, negative or zero. So let's have a look at how it is.
Now let's start with the second part, that is called the work. Now as we can see from the figure that these persons seems to be working. Now let's define precisely that what exactly is the work. Now work is said to be done when a force applied on the body displaces through a certain distance in the direction of force. This definition we must have done in the junior classes. Now what exactly are the details we're going to see in this part only. Now the topic is actually that is work done by the constant force. Now let's say that the F is the constant force. Now we can see it from the figure that F is being acted upon on the block. Now F is applied. So what we are doing, we are applying a force on the body such that it makes an angle theta with the horizontal, and it makes or it covers a displacement, or there is a displacement of the block along the x-axis. Now if we are going to resolve these component or the component of the force, we will get F cos theta which will be in the direction of this, and F sin theta which will be along the perpendicular or along the y-axis, if we will consider this as the x-axis and this as the y-axis. So we are going to get this F sin theta which will be perpendicular or along the y-axis, perpendicular to the displacement. So now let's see that since the body is being displaced in the direction of F cos theta, so therefore work done by this force in displacing the body through this distance will be F s cos theta, or the case we are considering it will be F d cos theta, or here also it is. So in general the formula is F dot s, where s represents the displacement. That is, this shows that this is the dot product or the scalar product. That means work is actually, it's the force F dot s. This is actually the definition of the work in the mathematical form. So now let's see. Now if there are many force if there are many force, let's say n forces are there which are simultaneously acting on the body. So what we can say about that? So now when all these forces are simultaneously acting on the body, so now what we can say, the body displaced, let's say body displaced from position R1 to R2. So what we can say that it displays from R1 to R2, its initial position vector is R1 and the final position vector is R2, something like this. If we're going to consider that the body is here and it comes over here, this is R1 vector, this is the position vector, this is R2 vector, and body goes in this. So this will be R2 minus R1. This R, so it will be R2 minus R1, so R will be equals to R2 minus R1. So therefore what we can say that the work done will be, as we can see, the work done will comes out to be the all those forces which are there, dot R2 minus R1, that is the displacement of the body. So this is the case when there are many forces, or if there are many forces which are acting simultaneously on the body. Now let's define what exactly is the nature of work done. Nature of work done means what exactly work done. Can it be a positive, can it be a negative, or what exactly it is. So positive work done means what exactly is the positive work? Positive work means that the force or its component is parallel to the displacement. As we can see from the figure that the force is making an angle theta with the displacement. That is, if we're going to again take the component, or if we're going to resolve this, what we're going to get, we're going this as the f sine theta, and this along the displacement we're going to get f cos theta. That means there is a component which is along the displacement. So therefore what we can say that the work will be positive, since this f sine theta will not contribute any work, because the angle, this component is making an angle 90 degree with the displacement. So therefore this 90 degree, this is making an angle 90 degree with the displacement, so therefore this will not contribute any, or this will not contribute in calculating work done. So what exactly, what does it signifies? It signifies that the external force favors the motion of the body. Now let's see an example for that. Like if we have this situation is, if we look at this situation, a person is lifting a block. Now if the person is lifting a block from the ground, so he has to apply some force in lifting that block. So therefore he has to apply some force in the upward direction, and when he is applying some force in the upward direction, so displacement will be along upward direction, so therefore displacement will be along this direction. So what exactly, so they are making an angle 0 with each other, since they are parallel, force and displacement are parallel to each other. So what we can say that the f dot s will be fs cos theta, or theta for this particular case will be 0. So what we can say, fs cos 0, so this work done will comes out to be fs. That means positive work. This is what exactly it is. That means what is it showing, that this person will going to do, or in lifting this block, person will going to do a positive work. We can see in other example, we can also see that if lawn roller is there, and this is so we are applying force in somewhat in this direction. So now if we are going to resolve this force, so this force, the component which will be there, if this is theta, let's say, so this will be f cos theta, and this will be f sin theta. So therefore, so since f sin theta will not contribute in calculating work done, because it is making an angle 90 degree with the displacement, so what we can say that it will only f cos theta will going to contribute in calculating work done. That means for this case also, the force component of the force is also in the parallel, or also the component of force is parallel to the displacement. So what we are going to get, work done which will going to come out, that will come out to be positive, and that is equals to fs cos theta, if let's say the s is the displacement. Now the second thing is that, can work be a negative? Yes, work can also be a negative. When it will going to get negative? Negative work means that force or its component is opposite to the displacement. That is, as we can see from the figure, that if we are going to take the component, so now displacement is along this direction. Now if we are going to take the components of this force, if we are going to take the component of this force, if this complete is theta, so what it will be, this will comes out to be 180 minus theta. So therefore it will have the component in this direction fx, and this as the fy. Let's say fx and fy are the component of these force. So therefore, in this case also fy will not going to contribute, as it is making an angle 90 degree with the displacement, so it will not going to contribute anywhere in calculating work. Only this component, that is the fx, which is along the negative x direction. As we can see that this displacement vector and this fx is making an angle 180 degree with each other. That means they are opposite to each other. So therefore cos 180 will comes out to be negative. So we know that cos 180 is minus 1. So therefore what we will going to get, the work done will comes out to be negative for this case. What exactly it signifies? It signifies that the negative work or the negative work signifies that the external force opposes the motion of the body. This is what it signifies. Or now the same example is here. Now we can check out the same example. Initially we had the force due to the person, which the force applied by the person in lifting the block. But since if that person will going to apply some force in the upward direction, mg, the weight force will always going to be there in the negative or in the vertical downward direction, something like this, as we can see. So mg will be, for the block, mg will always be along the vertical downward direction, but as the person is lifting this block, so force or the displacement will be along this along the vertically upward direction. This is the displacement. Now what we can say, that the force is acting in the downward direction and displacement is along the upward direction. Again they are making angle 180 degree. So we can say that F dot S, work done, is equals to F dot S, since F is equals to mg and displacement, let's say the displacement is S, so but cos 180 degree. So this will comes out to be minus mgs. So therefore what we got is that work done is negative. So since this, what does it exactly means, that this gravity work is opposing this motion. Now we can, as we can see it from another example, that if body is displacing along this direction, and if we assume that this surface between the block and the ground is rough. So therefore displacement is along this direction, positive x-axis. If we'll consider this as the x-axis and this as the y-axis, so if we're going to consider this, and what do we say, that the displacement is along the x-axis, so friction force will going to oppose this displacement. So therefore what we can say, that the force along the force of friction will be along negative x direction. Again the same thing is there, that the displacement and the force of friction are making an angle 180 degree. So therefore it will comes out to be negative work done. Now in the same thing, that now we have started about the positive work and the negative work. Now the third thing which is there, that is called the zero work. How there may be a situation where we get the zero work. So zero work means, first situation is there when the force is perpendicular to the displacement. As we can see that this pulley is doing some work in carrying this luggage. So what we can see, that the gravity force is acting in this direction, in the downward direction, and the pulley is moving along this direction. If we'll say that this is my y-axis, and the same thing, that is, this is my y-axis and this is my x-axis, so displacement is along minus x direction. So this is the direction of displacement, and this is the force of gravity which is always acting in the vertical downward direction. So what we can see from this, that the angle which it is making, the angle gravity force is making with the displacement is the 90 degree. So what we'll get, cos 90 will be 0. So what we'll get, work done will comes out to be 0. So therefore this is the case of this is the first case where we have the force is perpendicular to the displacement. Now the next thing is that if there is no displacement, that means if you are going to push, let's say this figure, as it is visible from this figure, that this person is trying to push this stone, but there is no displacement, as whatever the force it is applying in response, stone is applying the same force as we know from the Newton's third law of motion, that the action and the reaction force. So whatever action is there, in response the same reaction is there, so it is not being get displaced. So therefore for this case, if we consider this situation, displacement will be zero. So since there is no displacement but force is there, so therefore work will comes out to be zero. So this is the situation where we have no displacement. So since no displacement, so work done will comes out to be zero. And the last situation you can consider that if there is no force, then there will not be any work done. Now, what is the dimensions and the unit of the body, unit of the work? Now, if we'll talk about the dimensions work, now we know that the force has the dimensions as mlt minus 2, as it is being, as we can see it from here. So this, as it's mlt minus 2, this is force, and it gets multiplied with the displacement. Since work done has the formula as force into displacement, so force has the dimensions of mlt minus 2 and displacement has the dimensions as L. So therefore it will comes out to be ml square t minus 2, the dimensions for the work. Now this is the dimension of the work. Now what about the unit? As we know that the force has the unit as Newton and the displacement has the unit as meter. So the unit for the work is Newton meter. Now what we can say, or else we can use it as joules. The SI unit of the work is joule, or sometimes ergs. So this was all about the units and dimensions of the work. Now let's proceed. Now as we can see that the first example says that the body of mass 5 kgs is placed at the origin, means, and can move only on the x-axis. That means what it is showing that it is a one-dimensional motion and mass of the body is given to as 5 kgs. And now a force of 10 Newton is acting on it in a direction making an angle 60 degree. So what is given to us? Force is given to us as 10 Newtons. Okay, so now it's making an angle 60 degree with the x-axis. So theta is given to us as 60 degrees and displaces it along the x-axis by 4 meters. That means what exactly is the figure? That let's say this is the thing, that force is acting in this direction making an angle 60 degree. This is theta given to us as 60 degrees and this is making a displacement of 4 meters. This is given to us as 4 meters. Okay, now what is being asked that the work done by the force is Now as we know that the force is constant, that is called the 10 Newton. So what we can do, we can apply this as work done will be equals to F dot S. So that means F vector mod S vector mod cos theta. Since theta is given to us as 60 degrees and displacement is given to us as 4 meters. So what we can do, we can substitute, let's substitute the values. So 10 into 4 into cos 60. So what is the value of cos 60? Value of cos 60 is 1 by 2. So what exactly will be 10 into 4 into 1 by 2? So what we're going to get, it will comes out to be 20 joules. So if we look at the example 20 joules, so option D is the correct option for this example. Now let's move to question number 2. Now, so this question says a force F, that is 5 I cap plus 3 j cap Newton, is applied over a particle which displaces it from origin to a point R 2 I cap minus 1 j cap meters. Now work done, we are supposed to find it out that work done on the particle is, now force is equals to given to us as 5 I cap plus 3 j cap. Okay, this much newtons, and R is given to us as 2 I cap minus 1 j cap, this much meters. Now, so what do we know? That the work done is equals to, since force is again a constant, so what we can do, work done will be equals to F dot R vector. So therefore what we can write this as 5 I cap plus 3 j cap dot 2 I cap minus 1 j cap. Now what we can do, since what do we know that I cap dot I cap is 1 and I cap dot j cap is equals to 0. So what we can write? So the terms which will be left after taking a dot product, that will be 5 into 2 minus 3 into 1. So what we will going to get this as 10 minus 3, that is plus 7 joules. So the correct option is option number C. So the correct option for this is C, that is called the 7 joules. So work done is 7 joules for this question.
So guys, in this part we have studied that what is a work, and after that we have studied what is the nature of the work, and moreover we have studied that how can we calculate the work done when we have the constant force. Now let's apply this concept for the next part. Now for the next part we'll see that how we can calculate the work done when we have the gravity and the friction. So this is what we have to see. So for the next part, stay tuned with us.